It looks like we're live. Hello, everybody. Welcome back to yet another hangout. So, Riley said something rather stupid today. He actually said something correct today, which is rather a rare occurrence, but this has actually nothing to do with what we are going to talk about now. So, about 3 hours ago or something, Riley published a video called Density is a Demonstrable Force in Scientific Method. Relative density is gravity. So, with
that's a title.
Hey Sly, how are you?
What's up?
Okay, so Micro, Rumpus, and Sly are here with me today. Has either of you guys already seen his video?
I've just watched it.
I saw the title and commented on that and got trolled.
Mm-hmm.
This is about the air pressure one, right?
No.
No, density.
Oh, I thought this was about the air pressure one.
No.
Ah, damn it, I had this video already. Damn it. Okay, no, I haven't seen it.
Okay, so Sly, he actually published a new 45-second video maybe half an hour ago or something.
Okay.
And he actually got something right.
Okay, so it's not about Foucault.
No.
It's not about sunrise, sunset, or Snæfell, or St. Bees, or because none of that shit he got right.
No, something completely unrelated. But before we go into that, let's just see what he got wrong.
Okay.
So let's see.
45 seconds, so this should be only about a 3-hour hangout then.
No, well, no. The first video is about 6 minutes.
Oh, okay.
No, so
There are two videos on the table.
Okay.
well, one isn't really much of a video.
Okay, so apparently the audience can see it. Can you guys hear me all right? Apparently you can, because otherwise there would have been complaints already. Okay, for those who haven't seen it yet, by the way, hello, Mariah. How are you?
Chilling.
Okay, so from the title alone, quote, density is a demonstrable force in scientific method. A relative density is gravity, full stop. Mariah, any predictions?
No.
I predict pain.
I don't even know what all this shit is all about. I just jumped in.
Okay, then let's go.
If scientific method is the standard in the scientific community,
and the cause.
Hold on. If scientific method is the... You mean if the scientific method? You can't just say if scientific method.
Yeah, Riley, you know how you picked at me about my capitalization or my punctuation that I did in my Indiegogo test? Yeah, that's a pretty bad one right there, man.
Not only is the grammar really weird, but...
Well, no, because remember...
Is it fine for me to criticize the font?
I mean,
Well,
sure. No,
font is choice.
No, but like it's not really so much that he made I'm pointing out a grammatical mistake. Like, look at because if you look in the title in scientific method, like I don't think he understands what it actually is. Like he's using it weirdly.
Yeah, keep going.
Just wanted to keep that in mind.
Stop typing, Geo.
That's not me.
Oh, so that's me.
Oh.
Okay, let's continue.
Scientific experiment is the thing the experimenter deliberately manipulates to demonstrate the effect he believes he is observing.
then density is a force, despite the rumpus telling us for years that weight is a force, density is not a force. But not only
weight is a force.
A force.
I'm pretty sure Rumpus has never claimed that weight is a force.
Yes, it is a force.
Yeah, Micro, he's right.
Well,
Weight is a force.
it's the measurement of gravity's effect on a mass.
Gravity is the force.
Yeah, gravity is the force.
Weight is the result.
Right.
No, weight is a force. It's defined as it's got magnitude and direction. Weight is a force. It has
Micro. The acceleration causes the weight, and the weight is directly proportional to the mass of the object.
Right.
Therefore, the weight is a force.
I would consider the weight to be the result of a force.
Well,
anyways, we know what we mean.
The unit of the weight is newtons, so it is a force.
We know what we mean.
Well, no, I'm not sure you do. Weight.
Yes, I understand.
Weight is the gravitational force.
Yes, I know that.
Right. Good. And it's measured in newtons. It's a force. It's got all the attributes and dimensions of a force, and it is a force, and it's the force of gravity.
No, I'm looking up the definition here because I just wanted to make sure, because I've never heard somebody call weight a force before.
Okay.
Now, of course, weight does, force itself on other things, but that's because of gravity and mass and all that. But no, it actually says here, the weight of an object is the force of gravity on an object, which is what me and Micro were saying. And may be defined as the mass times the acceleration of gravity, weight times m or equals mg. Since the weight is a force, the SI unit is the Newton. Okay, so Newton is the force of a weight. Okay.
No, it's not the force weight. Newton is the unit you use to measure a force. Weight is a force, therefore it's also measured in newtons.
But in the same sentence, it also says here, density is mass times volume. I mean, so if he's going to try,
what are you reading from? I thought you were reading from Wikipedia or something.
Well, no, I just pulled it up here. I don't think it said times, but it said weight and volume. What do you call it? But I mean, it was just the first thing that I pulled up because I wanted to, I wanted to look up what
Yeah, that's fine. That's fine.
What's stated.
Yeah, it's always good to check slides. All good.
So it's actually treated as weight is treated as a force.
Correct. It is a force.
Yeah, because it is one.
All right.
It's calculated like a force. It fits the description of a force. It has the unit of a force. It is a force.
Fair enough. I just think it's like I wouldn't normally say like I would say it's the result, but whatever.
No, it is. No, it's explicitly a type of force.
Yes. Okay, I got that.
Yeah. Obviously, weight is often mixed up with mass itself, which is the problem here.
So I'm glad we cleared that up. Anyway, and the next line after weight is a force is the punch line. And the density is not a force. Yes, it's also the thing I stated. But
yeah, because density is not a force.
Yes.
No.
Its unit is
density is a characteristic of a mass. That's it.
Yeah, you calculate it by dividing the mass of an object by its volume. So.
But
yeah, its unit would be kilogram per cubic meter, for example.
Now there is a thing called force density, but not density being a force.
Force density. I haven't heard of what's force density?
The density of something when it's compressed. Hold on. I don't
think that's a term.
No, hold on. Force density. There's even an equation for it. The concept of force density arises both in continuum mechanics and electrostatics. The force density, or force per unit volume, is the net force on a region of matter divided by the volume that contains it. So it's basically like pressure.
No, it's per volume. It's not like pressure.
Yeah, pressure is per area, not per volume.
Yeah, that's
area, volume. Yeah,
but yeah, it's kind of similar to pressure, only that it deals with the volume instead of the area.
You could. Yeah, I must have not really heard that term before. But if you could say how much.
We're all learning something today because we didn't hear weight was a force. So
Well,
but look up force density. It is a thing, and because somebody tried to go at me that one time a while back, saying density is a force because there's a thing called force density, and
that's a very peculiar thing. That force density is not something you're going to come across except in some very strange circumstances.
Wikipedia says in fluid mechanics, the force density is the negative gradient of pressure. It has a physical dimension of force per unit volume. Force density is the vector field representing the flux density of the hydrostatic force within the bulk of a fluid.
Okay.
End quote.
Yes, that's
more garbage.
Yeah, and then the next bit is his page.
Anyway, by the way, the scientist in the side chat is making good point here. Force obviously is a vector because it has a direction, while density is a scalar.
Exactly.
Yes, exactly. That's one of the reasons why you can be so sure that it's not a force.
I mean, it completely shows you that Riley has no understanding of physics whatsoever, doesn't it?
Did we ever think he did?
No. But
I got one
at least
word
in the
for you,
beginning,
man.
we had to assume, or we had to give him the benefit of the doubt here.
I give you one word, man. Electrolysis. I'll just give you that.
For fuck's sake. Moving on.
Force. Density is the force. You science deniers tell us is actually gravity.
That's not me either.
So wait, the Rumpus has been telling everyone that density is not a force, but weight is a force? Why?
Yeah, exactly, because he's right.
Yeah.
Like, what the fuck?
Why is what is the okay, we're going to talk about scientific method. I just want to know this. Riley, if you're listening to me, I want you to display, if you're not going to do that in this video, I want to see a display of how how density is a force with a direction. And what causes that? Because you're talking about the scientific method. Get your buddy Quantum Eraser involved, since he likes to define the scientific method, or maybe even your buddy Oakley. Get them to actually show the cause of density having a direction and causing a force.
There's also another thing, Sly. Not only is it the problem with the direction, but what would an object of the same density with twice the mass cause in terms of what force would it feel upon itself, right?
Well, the weight would be the same.
No, not if it's twice the density.
Oh, I'm sorry. I had twice the size, but the same density.
Yeah, twice the size, but the same density. Therefore, double the mass.
I totally misunderstood your question. That's all.
Okay, so for example, you have a 1 liter bottle of water, and you measure the force with which it's pulled towards the center of the Earth, and you have a 2 liter bottle of water with the same density, obviously, because it's both water. If Riley said, or if he's saying that density is causing the force alone, then shouldn't the force be identical in both cases?
Exactly. He goes on about this. And when I've been hopefully going to engage them in a debate, I was always going to confront them with that. If they obsess with this idea of density being responsible, hold on. So if I have 1 kilogram of feathers and 2 kilograms of feathers and 1 kilogram of lead, which one has the greater force? It's not just a function of density, is it, you moron? It's a function of its weight, which is a function of its mass. They don't understand. It's just so stupid. It's incredible.
I have an observation that actually that they can't explain regarding density. So if you have a density column and you have 1 kilogram of a more dense substance underneath a 10 kilogram substance that's less dense, let's say, of course, the 10 kilogram less dense substance is going to sit on top of the 1 kilogram more dense substance in the density tower. Now separate those two into separate density towers and put them on a scale, and the less dense will actually tilt down the scale. So there's more force being applied upon that, but the displacement is still more by the more dense. So you're still going to get a density column, but it doesn't matter because it's not a function of weight. It's a function of density and gravity.
Or here's another thing. Now I did this a while back, and this was an argument between Riley and myself, and he was too stupid to understand it. The acceleration of gravity is affecting all things equally. Now, obviously, when you have combined objects and a mass and stuff like that, one's going to be way more than the other, et cetera, et cetera, et cetera. But the gravitational acceleration affects all things equally. So that's how the 0G aircraft actually can function. And I did a video on this, and he actually mocked the video afterwards because he, like I said, he was too dumb to get the point. And that is, when you got these people in these 0G planes, floating around and throwing gummy bears at each other and, squeezing water out of bottles and stuff like that, all of those things are falling at the same speed. It has nothing to do with their density. It has nothing to do with the amount of mass in each object, because if it did, then as soon as, like the example I used in there was a woman who had a bunch of, I guess they look like M&Ms, and she let the M&Ms go and they kind of went in all different directions. If density was a force, then she would have been, and she was floating, then she should have let go of those M&Ms and they would have shot straight to the roof of the aircraft. Because of the fact they are less dense.
Than she is, yeah.
So the point of that being, Riley, we've already been down this road, and you already know all of the examples that exist. Because if not, you would be sitting there, and if you had if you had a fat guy, a middle guy, and a thin guy sitting on that plane, they would all be flying at different times of the parabola.
Yeah.
Have any of y'all done the phone drop test where you record your screen and turn on an accelerometer in your phone and drop your phone and notice that the acceleration force of gravity disappears?
No, I haven't tried that.
Now my smartphone is
Okay.
actually shit, so no.
So
All
check
the more
this out,
reason to
Sly. Sly, you got a good phone? Yes or no?
I got
You got
a
a good-
Galaxy S5. It's got everything it needs.
Go ahead and look up online. There, look up on your store. We can do this right now. It's this simple, right? Look up on the store and download a like an accelerometer, something that tells you what acceleration you're under. And you'll notice that it'll have an XYZ acceleration. And as you're standing still, let's say you're holding your phone in portrait, right?
Right.
I believe that the Y going down, I believe is going to be the Y is going to be the bottom of your phone. It's either the X or the Y is the bottom of your phone relative to the 3-position axis, right? You'll hold your phone up and you'll notice it'll be under constant acceleration of 9.8 meters per second. Now get a screen recorder, record that screen and drop the phone onto your bed or some pillows or something. During free
A
fall,
concrete floor.
Yeah.
no, not the concrete floor. Don't listen to that guy. He will be fine because he's a gelatinous material. Your phone will not. Your S8 will be not. It's non-gelatinous.
My
But
phone
as you
will be
drop
fine.
it,
That's a case.
as you drop it, the accelerating force is actually nullified.
It goes
because
null,
it's under it's under acceleration, and there's an inertial force in the opposite direction that's also pulling you back, trying to keep you in the place you're in. So you're under two different accelerations in free fall. You're under one acceleration towards the Earth, but you're also under another acceleration towards being pulled backwards in your inertial force. I believe that's.
I'm gonna have to disagree with you there, I'm afraid.
Yeah, me too.
Okay. Well, I might be.
But I have one question though. I have one question. This would be cool to do. I'll bet you, depending on the sensitivity of the app that you're using, as far as its refresh rate, that it does its displays. I wonder if you were to time that drop, if you could get from that, because I'm sure you could. There's got to be the math for it. If you could get the weight of the phone.
Yes, you can.
Yeah, you can look that like that's part of the you can get that in the specifications.
Yeah, I mean that's what I'm.
Sorry. How can you get the weight of the phone?
If we were to do this drop test, right? And
okay, now I see what you mean.
Oh no, wait a second.
Yeah, you can't get the mass of the phone. Sorry, I don't say you can get the weight of the phone.
Well,
yeah,
because
Rumpus is right.
Would
Because
you get it?
No.
Because the point is the acceleration due to gravity is independent of your mass.
Yes, as long as there's no drag from the air, you actually are not able to determine the mass of something. This is why in a vacuum, for example, a feather and a bowling ball fall at the same speed.
No. I got you on that, but I mean, wouldn't you be able to calculate something about inertia on this?
No. Because the whole point about mass and gravity is that the force on the thing is directly proportional to the amount of stuff. So the point is, every little bit of stuff, no matter how small or big, the force goes up with it in linear with the amount of stuff there. So you can't distinguish that the acceleration is going to be exactly the same for a little bit of stuff and a lot of stuff, because the force on it goes up exactly the same amount as you increase the amount of stuff.
Can y'all tell me
that's
where
what makes things accelerate.
Y'all said I got something wrong, and then y'all just passed off.
Yeah, team. There's actually no force holding you back when you accelerate. This is why you accelerate.
Right, it's a fictitious force.
Wait,
hold on.
Shall I draw a diagram on it? I've got three things I want to present. Oh God!
Yeah. So the only force that you would feel in that scenario would be the air drag after a while.
Okay, can I deal with that? But I'd just like first of all to deal with this thing of we were talking earlier
Rumpus, we're not done with the video yet, buddy.
Yeah, I know. This is relevant to the video.
Yeah, I know, but it's going to.
Hold on. You had a discussion about your thing about falling a plane. I want to give an example of something density in a plane. So you give your example. I'd like to give mine. Thank you very much.
Hear your examples, dude.
Okay, Rumpus, let's do a quick one. So I'm gonna present you for a second.
Right, so here we go. Sly was describing something in an aeroplane. I'm describing something here in space. I've got two vessels, two spheres, and I've got in glass containers, and this is in space. Now, Anthony Riley says the only thing you need to know about is relative density. So imagine I now cracked these two spheres and let them go. And inside the blue one is a density that's greater than the density of the liquid around it. So this vector we were talking about, and Sly was talking about in the aeroplane, and so was Team Skeptic. What happens now? Because he was talking about putting a denser thing underneath the density thing, the density range in the column. Where does the density dictate that something should go in this situation? What's the rule? Where's the direction coming from? We've got a dense thing in the middle and an outer layer of something's less dense. What's the direction of movement? And I asked Anthony this very thing about a month ago, and he said, well, obviously the denser stuff and the blue stuff will go down the screen.
Oh, for fuck's sake.
And then leaving the other stuff. But of course, what happens if we're here? There's no... and that rather shocked him, because of course there's no direction from the density. There's nothing about this density that has direction. The only direction comes, so you cannot just have relative density being the information. You need more information. You need to know where the force, the gravitational field is doing, giving you the direction. There's nothing about this in this, what I've got here, that's enough to tell you what the hell is going to happen. So that's that part. Now I want to get onto this thing, the falling thing with inertial force quickly. That Team Skeptic was, and why you feel the force of gravity. So if you've got two things.
No, I understand that. Okay. Just go explain to me what I was wrong about. Why, when something falls, it doesn't register an accelerating force.
Right. Okay. That's another thing. It was the third thing I wanted to mention. So if we have, imagine these are two cells in your body. Here, in fact, actually, no. Here is the sensor. Imagine this is. In fact, I can draw the sensor inside the meme sensor. It looks something like this. It's got two things that come to one another like this, and they've got little indentations in them. A little cone-like feature. Let me just change this arrange. Yes, I'll do it for that rather than the. And think so. They've got a little cone-like feature. So if I click on that, damn it! If I click on this, just try and show you. Sorry, again. Sorry about this. Nearly there. Right. Oh, you bastard! Right. Go there. Right. So we have something here, and hopefully,
Okay, Rumpus, I think, can you prepare this while we are continuing with the video?
Okay, I'll do that. Yeah.
Okay. So let's continue with the video.
How did he do that, bruv? What a muppet.
Because the Rumpus is lying.
And the discovery was made then in the discovery of quantum mechanics, first in the behavior of light and then in the behavior of matter, and finally culminating in 1926 with the full equation of quantum mechanics, which told us that the laws of motion of Newton were not right and had to be modified to other laws, which are quantum laws of motion. And when this quantum laws of motion...
Stop. Okay, so that Feynman quote. What Riley apparently doesn't show or doesn't understand, one of the two, is that Newton's laws work pretty much perfectly unless you go into the very fast things or when you deal with very small things. So in everyday mechanics, we can use Newton's laws perfectly. They do everything we need them for. But as soon as as soon as you start dealing with atoms, molecules, small particles, Newton's laws will show to start.
Well,
for example,
I think
they will start to show inaccuracies.
Right. That's what I was going to say. The actual definition of a scientific law, which gets lost on people who don't take the time to understand science, is that a scientific law is a law under ideal circumstances. So Newton's laws of motion may not apply at the quantum level, but that's not the ideal circumstance that the law is based around. So it doesn't nullify the law. The law is not going to give us an inaccurate reading of reality because we're not dealing with the special circumstances of quantum mechanics.
Yes, and obviously the same applies for relativity as well. As soon as an object is moving close to the speed of light, Newton's laws do not longer
right.
They are no longer valid. They do no longer work. Because, for example, as you try to accelerate,
Newton's stuff only works at slower speeds, right?
Yeah, as for example, in relativity, when you're close to the speed of light and you want to accelerate more, what's gonna happen is you're not gonna get much faster, but you're just gonna get heavier.
Mm-hmm.
Which is one example where Newton doesn't work. But as long as you deal with small speeds, like let's say everything 10% of the speed of light or slower, there's no reason to use relativity whatsoever.
Yeah.
So basically, everything on Earth follows Newton's laws.
Yes.
Well,
Except for electrons and
everything in macro scale. Yeah.
Yeah, but what do you call it? But ultimately, the laws of physics apply to Newton's laws of physics apply to everything that is in motion on the Earth.
Yes, which is why, for example,
that is considered slow-moving stuff.
Yeah. For example, no aerospace engineer is gonna use relativistic equations for anything
because it's just stupid. Like it's more work than you need to do.
Yeah, it makes the entire work too complicated and unnecessarily complicated for what they're actually trying to calculate.
And which is why Feynman would bring this up in a discussion about quantum mechanics and also discussing things like relativity and stuff like that. That's saying it's beyond Newton's equations.
It's almost as if Feynman dealt a lot with particle physics.
Or physics in general, yeah, it's weird. I'm pretty sure Feynman would facepalm as well if he had the opportunity to talk to flat earthers.
Mm-hmm.
He would implode.
Maybe.
I don't know if implosion would be it. No,
I just wanted to say the word.
Yeah.
Well, probably he'll start rotating in his grave in such a way that all our energy problems would be solved immediately.
There you go.
Unless he was cremated.
Even then. Okay, continuing.
So yesterday's show, we dealt with the notion of gravity and whether it's a force or not. And I made numerous points and qualified it. Now, I've had some critical feedback from somebody that I respect. I'm not going to say who because I didn't ask whether I could reveal his name or not. But this is what he said to me. He said, please rewatch Bob's point about acceleration and address tomorrow. I tuned into the debates early this morning, especially to hear mine and Nathan's take on it. And I felt that you both failed to address the point. I didn't. The point's been missed. I'll remake the point and I'll show why it's been addressed while I'm doing it. Bob is saying that there is an acceleration. What he means to say is Bob is saying that there is a force. I'm not saying that is or isn't, but I do see his point, and I felt that nobody, you, Nathan, or Arwin, addressed his point at all. I agreed with what you said, but Bob's point is very specific to acceleration. If it's simply relative density, which is my belief as of today, then why do things accelerate down and not up? Please come in tomorrow. I will try to listen in.
Yep.
Oh, I'm all ears.
So this is exactly the point that Rumpus earlier made. When you have two different objects, for example, fluids with two different densities, how does the acceleration happen? In what direction does it happen, right?
Yeah. How does density choose its direction?
Yeah.
In their definition.
Which of the two fluids is gonna end up where? So, any predictions on what Riley's gonna claim?
No, I'm not like. I really don't know. Like the problem is I really can't figure out a way. Like because it obviously doesn't work. I have no idea. I can't figure out a way that it would work. So.
Rumpus, can you do us a favor? Can you mute yourself when you're typing? Apparently, you're rather loud today.
Oh, sorry.
The audience can hear that.
Apologies.
Okay, speaking of loud, I'm going to have to catch up with you guys in a minute here. I got to eat.
Okay. Team Skeptic, do you have any predictions on what Riley's going to say?
I don't know how he's going to be able to explain this way without the vector force. I don't know how he's going to be able to do it.
Okay, then let's see.
So, right at the beginning of the presentation yesterday, I gave the definition of and explained fully vector. Vector as it's stated on screen, is a quantity having direction as well as magnitude. And then in the bit in blue, that's the important bit, especially is determining the position of one point in space relative to another. This is the point that's been missed. This is the point that I did point at Bob and say, perhaps he's forgotten this.
Stop. Okay. After reading this definition, what mistake, critical mistake, unexcusable mistake is Riley gonna do? Here's a little hint. It has something to do with one single word of the definition.
I can't read what it says on the screen.
Let me.
Is it space?
No. For fuck's sake, wait a second. Ah, there we go. That's the problem. Can you read it now?
Yes.
Okay, so the passage that's highlighted says, especially as determining the position of one point in space relative to another.
Oh, is he gonna ignore the especially?
Nope, it's worse. Okay, let's not solve this puzzle right now. Let's just I'm gonna throw you into the cold water here because it's gonna get stupid. And by the way, before you facepalm, please mute yourselves.
Alex, did you George wants to come in and describe how meme things in phones work? Did you see my message? I don't know if you're interested in his own contribution.
Which George?
George Natayuk.
Sure. Do you have his?
Yeah. Okay.
Address?
I'll give it. Shall I give him the? Yeah. I'll give him.
Yeah. Just send him the link.
Okay.
In the meantime.
Yeah, Carol.
Everybody ready for the stupid?
Oh dear.
Well, in the egg scenario, the vector is created by the medium and the egg itself, and it's the relative densities of both. Now, I've highlighted Nora's comment, and I'm going to state on the record again that, in my opinion, Nora is disinfo on this topic, because Nora is not just disagreeing with me; she's literally going against scientific method.
I used it again in this weird way. What the hell?
Yeah, like.
Okay, welcome, George. How are you? George? We
Come on,
can't
George.
hear you. Please check whether you have set up the right microphone.
Hello?
There we can hear
there
you.
we go.
Yeah. Hey, George.
Yeah, I've been through this so many times with Riley in the past, Geo. The basic problem you're going to have with Riley, of course, is he doesn't accept that forces are responsible for the movement of objects in a medium. And until you get over that hill with him, you're not going to get anywhere.
Well,
the real simple explanation, of course, and I've pointed this out to these flat earthers and Riley, is when you have an object immersed in a medium such as air or in water or whatever, you have what we call the free space weight. That is the weight of the object in, say, a vacuum. You can weigh it. That weight does not change when you move it into a medium, the free space weight. The net weight or the net apparent force on the object does, because you have two forces at play here. You have the free space weight, which you have when you measure the weight of the object, say, in a vacuum, and then you have the buoyant force acting in an opposite direction.
Yeah, and obviously the relative weight is the sum of both.
Yeah, right. So it's a very easy explanation. If the buoyant force exceeds the free space weight of the object rises. If the buoyant force is less than the free space weight, the object sinks. That's it.
I was actually hoping, George, you would want to talk about this using phones actually to measure the G-force, and I've got a diagram here that you probably.
I wasn't watching.
Right.
I just got in from raking. What is this about?
Oh, right. This is I'm describing the mechanism of how a meme works. As Team Skeptic here was asking about how come a phone when you drop it shows a 0 G, and I was just describing your little comb thing here that you've mentioned.
I understand the concept. I understand. I wasn't really asking. I completely understand the concept.
Okay, completely understand. Okay, what happens then? The idea of why you get 0G, and the point is that you feel 0G when you're in the vomit comet, because if you think of your, perhaps I'll draw two. Imagine if there are two cells in your body, for instance. If I draw down here, one cell in your body and another cell in your body here. That's the way you register force in your body, is whether or not one cell in your body is compressing another. But if both of these things are falling,
no.
Yes, if they're both of these things are falling at the same rate, even though they're accelerating, then
there's no net acceleration between the two.
Exactly. There's no differential acceleration between the two. Therefore, they will not feel any force. So the reason you feel force when you're standing up is that you're being accelerated toward the center of the earth, all the mass of your things, but your feet are then stopped by the earth and they push back up. And so there's a net force between I'm just picking on two cells here, but you can just imagine this is two parts of your body, if you like. The one is having to be pushed up by the reaction of the ground this way, but that ceases to exist. And so if there's no force upwards from the ground, there's no differential force between any part of your body. Therefore, you do not feel any forces as a result of being in free fall. And that's why also up here was I was drawing this mechanism for how things phones detect acceleration. If there's no net acceleration between them because they're both moving down at the same speed, then they're going to go into the non-acceleration position if there's no difference between them. So
there won't be any relative movement between these two plates of the capacitor.
Exactly. And
yeah,
so
as long as both plates are not accelerated at the same rate or in different directions.
And of course, if they're not accelerating, this one, in other words, the one at the top is being held up by some part of the mechanism in the so that this is held by some part of the phone.
Yeah, actually, it can be both ways. It just depends on how the springs are designed, whether they are designed to push the
exactly. I'm just
draw them together.
Yeah, I'm just doing a simplified one direction.
Yeah, another way to look at this free fall thing is, say, take a bathroom scale, put it on your stand on it, you register a weight because your weight is pushing down on this scale that's being held up by the earth. Now, go up in a balloon and jump out with your scale and put the scale under your feet. It will register 0 because both the scale and you are accelerating at the same rate, and this all comes down to the equivalence principle in general relativity, is that you cannot tell the difference between an accelerated reference frame and being inside a gravitational field. So if you're an accelerated frame that's falling towards the center of the earth, then it just negates the gravity.
Yeah,
right.
So
which is basically Newton's third law of motion.
And so the key,
you're getting a force pulling you down, and you're getting an equal force pushing you up, and those two forces net 0, and that's the force felt on everything that's in free fall within the gravitation.
No, skeptic, you're wrong.
No,
there's only a net in this situation I'm describing here, or in the situation
there is in free fall. There is no force on you in a manner of speaking.
Well,
you're still accelerating. No, you're still accelerating.
You're accelerating, but you don't feel anything. That's
that's different. So in other words, going back to these two cells in your body that Micro didn't seem to like me using as an example. If there's no difference between the acceleration between these two, there's no force there's no relative force, but they're still being both accelerated. So I'm a bit confused why Team Skeptic. There's no other force involved here, Skeptic. There's just a force pulling your two cells. Imagine the two cells of your body, both are being pulled down. There is no resistive force. There's no force in the other direction. It's just simply its mass.
Team Skeptic,
it's inertia.
Stop. Guys, everybody stop. Team Skeptic, the opposite reaction, which I agree with you must be there somewhere, is that the Earth is actually being accelerated towards you. So the only two forces that are happening here are the two objects, or the two cells being accelerated towards the planet, and the planet being accelerated towards the Earth. Those two forces are going to be identical.
What everybody is trying to tell you here is there's no differential forces. Everything in your body in free fall or any object has the same force on it. The same gravitational force. There are no differential forces that you have like when you're standing on the surface of the earth. There is a differential force down at your feet.
Yeah, this is the thing that Team Skeptic, though, was also making another point, George. He seemed to think there was another force some other force involved that was pulling you up or something, which I
no, I know. I'm saying that does not exist.
Okay.
Every atom of the body has the same force on it. There are no differential forces that you can detect.
Let me ask a question. When you are in a car and you begin to accelerate, you feel a force pulling you backwards, right?
You feel the seat pushing.
You feel it.
Yes.
No, the seat pushes on your back.
To you, you feel like you're being pulled backwards. It's
not
that.
But you aren't Team Skeptic. What's actually happening is that the car's being accelerated underneath you, and you're not.
This is the exact same thing as the equivalence principle, guys.
No.
The equivalence principle is the equivalence of gravity. Let's not get confused between gravity and force.
Team Skeptic. When the car is being accelerated, only the car itself is accelerated. You are not being directly accelerated. Therefore, the inertia that you have will try to keep you where you are. And
let me ask you a question.
Wait a second. I'm not finished. When the car accelerates underneath you, you will be pressed against your seat because the car is trying to push you forward. When you are in a gravitational field, this is not the case because every single individual atom in your body will feel the same 9.81 meters per square second.
That's right. The gravity is very special.
Planet.
Yeah, because the thing about gravity is so special, as Alex is pointing out, every atom is being pulled together, whereas in a car, it's only your back that's being accelerated. Your back and your bottom are being forced. That's where the force is external to your body, whereas with gravity, it's every single atom.
Let me ask the question I was trying to ask. Let's say that you're in a car and the car is completely blacked out. All right. How would you know that it was the car pushing you forward and not something pulling you backwards?
You wouldn't know the difference.
Oh, thank you.
But that's not the equivalence principle. Yeah, but
I didn't say it was the equivalence principle. I said it's basically the same thing as the equivalence principle. You don't know because inside the frame of reference, you have the force pulling you backwards, which is felt. It doesn't mean that it's there. It's obviously the car pushing you forward, but it's felt in the opposite and equal direction.
Right, but you made another point earlier about the fact you thought there was some sort of inertial force going in the other way. Are you now happy that's not existing?
Well, it's still going to exist with an object that's in acceleration. You're still going to feel it.
There's no other force. There's a reaction. There's an equal opposite reaction, if that's what you mean.
So, I might have said inertial force as mistakenly. That's why I said, hold on, if I need to be corrected on that. But I'm trying to explain things based on Newton's third law of motion here.
Yes, I mean obviously if I've got this star here and I then exert a force on it in this direction, then obviously, as Alex said, let me just it takes a little bit of time to bring up a bloody pointy thing. So if I apply a force in that direction, obviously the object pings back with a force in that direction. But it's this so at this point here, there are two forces that come together, an equal opposite reaction. But you were saying, so if you meant by inertial force,
the desire for it to stay where it was at when it began its free fall. So as it accelerates towards the Earth, it has the Earth acceleration. Which is where I made the mistake. I was trying to explain the third law of motion there, not the first law of motion. But what I was saying is I used the words inertial force, and that's why I go, I think I'm wrong there. But that was at the very, very beginning. I'm trying to explain this in terms of Newton's third law of motion, which with the equal and opposite reaction, when you're falling down, it feels as if you're falling up as well. Those two contradicting forces will give you a net zero force.
No. Team Skeptic, there's only one force that applies on you, and that is the force of gravity. There's no force in the opposite direction. The only secondary force that's happening there... The only second force that's happening there is the planet actually being accelerated towards you.
Yeah, this is the car situation where there is a reaction to the outside, but in the case of the falling, there is no opposing force at all. So as Alex says, it's the opposing force is the one pulling on the Earth.
Actually, I think the best analogy here is the tug-of-war, right? Because what you're doing is you're pulling, your gravitational field is pulling on the Earth, and the gravitational field of the Earth is pulling on you.
Whereas in a car, it's at a particular boundary. You have a boundary of the seat, which is pushing on you, and then you're pushing back on the seat. But there's nothing to push back. Because to push back, whereas with the Earth case, all the atoms, there's nothing. There's nothing for it. There's no other force except the one reaction of the Earth. So Alex is completely correct.
Okay, shall we continue?
Yeah.
Actually, I just want to point out why I disagreed with Rumpus with the cells.
With my 2 cells, right?
So the way force is felt in your body with is by mechanoreceptors, which are a type of nerve cells. What they're actually sensing is not the force between the 2 cells. What they're sensing is the change in density in the cell membrane.
Right, okay, but that must be caused by a force.
Well, yeah, but
yeah, it's a way. It's basically, Micro. Is it fine to use a balloon filled with water as an analogy?
Sure.
Like if you measure the mechanical stress inside the balloon's membrane, you could actually determine on how much weight is put on it.
Yes, that's which. So I just because there is a difference between the two in terms of how a biological system in terms of a biological system. So I just wanted to make that clear.
Right. So in other words, what actually is the thing? What is the sensory apparatus inside the cell that what has it actually got in it? And doesn't I did guess it'd be something rather like this, where 2 things are forced together somewhat more than they were. But you're saying it's actually there's a change of density of the material inside. Okay.
Yeah, it's a change in the density of the cell membrane, and then you have transmembrane protein like ion channels that will change their structure depending on how many are around them.
Oh, right. So the density of the fluid they're in actually changes their conformation. Right. Right. Amazing. Because I suppose they're like little springs, aren't they? I suppose it's like
Anyways, move on. I just wanted to point out.
Well, with the hydrogen bonds, I mean, the proteins can change shape because they're springy. Is that not correct?
We'll get off sidetrack.
Okay, springy is no. Okay, let's.
I just wanted to explain why I said no.
Okay.
Everybody ready?
Yep.
All is ignore scientific method. Nora is literally rejecting it and arguing something else. The problem is, Mark and Arwin, and I know he's going to jump on me, but bear with me, both support this, and Bob agrees with them. But it's one thing to ignore scientific method, but it's a whole new ball game to go against it, because you're redefining the thing that is defined as science. So Nora says, here's Sleeping Warrior talking about vectors when he doesn't believe in up and down. Do I sense a contradiction? No. There's no contradiction, because the bit in blue specifically states that it's relative, especially as determining the position of one point in space relative to another. So to address Nora's point, no, there's no contradiction, because I'm specifically dealing with relativity. Okay, it's relative.
Can you stop it there? He's talking about relativity. What he's not, he's getting mixed up between relative forces and what's relative, because he's talking about vectors here, which is directions, but he's just saying relative in general. Could be relative scalar things. What we were interested in is relative forces, and those are vectors. But he's got confused between relativity in the sense of just being anything that you can measure together, and that could be the relative densities does not equate to relative vectors. Finished.
Yeah, well, basically, when you want to describe the positions of 2 objects in correlation to one another, first of all, you just make it easy and define one of them as being in the center of the coordinate system.
Hey,
right?
Gio?
Yeah? You just muted yourself, George.
Oh, there I am. Okay. One of Riley's favorite tactics is to take a sentence or a part of a sentence literally and ignore the rest of the sentence. Okay. I went through this with him on neutral buoyancy, and he's always brought up a Wikipedia page on neutral buoyancy, and it reads, neutral buoyancy occurs when an object's average density is equal to the density of the fluid in which it is immersed. That's what he focused on. Aha, you see, it's density. But if you continue reading...
Stop. I was about to say, let me guess. The sentence continues saying that gravity is required in both cases.
Yeah, well, I'll read it. I'll read the whole sentence now. Neutral buoyancy occurs when an object's average density is equal to the density of the fluid in which it is immersed, comma, resulting in the buoyant force balancing the force of gravity that would otherwise cause the object to sink if the body's density is greater than the density of the fluid in which it is immersed, or rise if it's less.
Well, that's a typical quote mine.
Yeah, well, he ignores anything to do with force. His claim is density neutral, or buoyancy, neutral buoyancy is only due to densities, and he ignores anything to do with force. And like I said, he parses a thing out. He just focuses on the first part of the sentence and ignores anything to do with force. And then if you go to buoyancy in Wikipedia, buoyancy or upthrust is the upward force exerted by a fluid that opposes the weight of an immersed object. Again, it's forces. It's a balancing of forces, but he ignores all this. He just focuses on those parts of an explanation that fits his narrative.
And let's not forget now, he's now claiming density is a force, as we saw in the start of
Yeah. Oh my God.
You missed that bit, George. At the very start of this, he said, I claim that density was not a force. He quoted me as saying, weight is a force, density is not a force. And
yeah,
said,
George, just take a look at the title of his video. Density is a demonstrable force in scientific method. Relative density is gravity.
Yeah. So he's prepared to talk about forces with density, providing you call density a force. And apparently it's a demonstrable force. It's not in the scientific method. I mean, this whole bit, this section here where he gets involved in the Nathan quantum eraser dogma of something. He's so embracing this dependent variable. He's actually thrown away any sort of logic to do with Newton's forces and things, and he's just starting to talk about independent variables as justifying whether or not density is a force. Have you seen this, George? He goes on, and he's going to go on now and he's trying to equate because density is some sort of independent variable. He's thinking, therefore, he thinks that has to be a force. That's his reasoning. Sure. You will see it as he goes on. It's insane.
Yeah, I'll let you guys continue on. I'm going to go and finish up with my yard work. I just happened to catch a little bit of this over on Skype, and so I just thought I'd come in and say hello to Gio and the rest of you.
All right. Thank you very much for joining, by the way.
One thing that was said, you were saying earlier when I first came in, Gio, regarding Feynman and Newton's laws. You were explaining correctly, but I think maybe an easier way to look at this is that laws are valid within the constraints imposed on them. Laws aren't necessarily universal and all encompassing, like Newton's laws of force or quantum mechanics or general relativity. Particularly Newton's laws are valid within the confines with which those laws are defined. And we know, as you pointed out, they don't work at the very small level down at quantum mechanics, or they don't work up at gigantic masses dealing with the masses of the collection of several galaxies. It tends to fall apart. But within those two extremes, it's perfectly valid. It gives us very good results. And what Feynman said, if you go back and from Riley's video where he again quote mined this thing, Feynman qualified it and said Newton's laws work or do not work without modification, but what he could have expounded upon is within these extremes. Newton's laws work. They are a subset of the general relativity theory. If you, as you pointed out,
basically
the macroscopic masses that we're used to and reasonable velocities, Newton's law or the general relativity theory and the special relativity theory reduces down to Newton's laws.
Yeah, but basically, Newton's laws are well. What happens is that when the Lorentz factor within relativistic equations, there's a thing called the Lorentz factor, right? And what it describes is
if you expand out the Lorentz factor, it's 1 over the square root of 1 minus the quantity v over c squared.
Yes, exactly. So when you're close, when you're close to the speed of light, this Lorentz factor gets closer to 0. And the closer you are to 1, the more accurate Newton's laws become.
Yeah. Well, the thing is you don't have to go that much slower than the speed of light, like within 100th of the speed of light. Newton's laws are accurate to within several parts per million. You don't have to go that slow in order for Newton's laws quite accurate.
I think the border or the boundary that's usually drawn is at 10% of the speed of light.
Yeah,
exactly. That's when you get 1% of error between the two.
Yeah, I said if you go to 100th, though, you're within several parts per million of accuracy. Sure, it depends upon what you want to establish as an accuracy bound. But the thing is, if you look at the Lorentz factor, 1 over the square root of 1 minus v over c squared, you expand it into a Taylor series, you will find that contained within that expansion in the first few terms, you'll end up with rest energy. Then you'll end up with 1/2 mv squared, which is the traditional kinetic energy term. And then there's higher order terms that drop out very fast because they tend to be like v over c to the 4th power, v over c to the 6th power, and they drop out very quickly as v over c reduces, down below a tenth of c. So the thing is what I'm trying to say is within the special relativity theory and the Lorentz factor, Newton's laws are contained in there. They're a subset of it. That's all. So
subset. I wouldn't call them a subset. I'd call them a special case.
You can derive them.
Well, no, it's not a special case at all. It's a subset. It's contained within there as your velocity starts decreasing below c, everything reduces to Newton's laws.
Yeah, Alex, he's making the point that it's actually the same equation, and then just the cube and the cortex factors that just fall out of the equation.
So you
could argue that it is actually the same equation, and it's just simply the higher order things fall out.
Yeah, you ignore the higher order terms. That's all. They start.
So it's the same with quantum mechanics. It's the same with quantum mechanics when the Planck quantum. How the fuck is it called in English? German, it's Planck's Wirkungsquantum. When that term becomes zero,
quantum vacuum. That's. I mean,
I actually don't know the English term. No idea.
I'm just trying to translate it directly.
Basically, when that becomes zero, then many of the rules in quantum mechanics actually become Newtonian rules.
But what I'm trying to say is that Newton's laws are contained within the special relativity laws if you reduce v much below c. That's what I mean. It's a subset. It's in there. You can start ignoring the higher order terms, start neglecting them because they become insignificant as v becomes a fraction of the speed of light. So it's in there. They're all in there. Newton's laws are in there. It's just that as your velocities start becoming an appreciable fraction or a much smaller fraction of the speed of light.
So we can think of the relativity laws as an extension of Newton. It's not as though they replace them. It's just simply adding in the higher order terms.
Yeah, and that's what Feynman was saying, is the Newton's laws just have to be modified to encompass these other extremes of
you don't delete Newton's laws. They're still there, present in the equation. You've just extended the equation.
Exactly. Yeah.
Okay. Well, thanks, George.
Later.
Bye. Thanks for joining.
Yep.
Okay. By the way, Team and Sly, are you still here at the moment? Because for the audience, both of them are muted.
Which probably means no.
Well, Sly apparently
no,
is
I am.
Oh,
you are.
No, I am. I just had it muted so that way I could. I'm taking care of a few things around my shop right now while I participate.
Okay. Anything you want to add?
Other than Anthony Riley didn't know what the fuck he's talking about. Yeah, I mean that's. But I think
just
everybody
given.
knows that. Yeah, I think everybody fucking knows that.
Okay.
More garbage.
Yeah, we still have 2.5 minutes actually to
Hey,
go.
just out of curiosity, did y'all catch Nathan Thompson or not Nathan Oakley and Quantum Eraser talking about the different, not understanding the difference between zeros and infinitesimally small?
No, I missed that.
Oh, you got to watch that one. That one's great.
I saw a bit of them today, though. They were going on about thinking that on the spherical model, that the Pontchartrain bridge, the height of the different edges of the bridge should be at different heights. I cannot believe they still don't understand the basic geometry of a sphere. Amazing display, and they were saying, where's this drop gone and all these curves, why isn't it humping in the middle? They still don't understand that the definition of height is the distance between whatever it is and the radius and the center of the earth. They still think
yes, I know.
I mean, it's so basic, but they're never going to get it, I think. I mean,
that's why when I debated the guy on non-sec the other night, I was like, just explain to me what you think I believe in. Just tell me what my beliefs are for just a moment so I can make sure that we're on the same page. And he couldn't do it. Yeah. He's like, because to acknowledge my beliefs, then it acknowledges my argument, then it makes my argument valid, and you have to answer it. If you don't acknowledge my beliefs, then there's no way you can, wherever we're talking about, I'm arguing that apples are red, and you're arguing that oranges are orange, and we're both fucking not getting anywhere.
Yeah, Skeptic, you have to draw a diagram. In the case of that, I draw a diagram of the Earth and say, look, these 2 points at the opposite sides of the Earth are at the same height. Because they're the same distance from the center of the Earth, and that's only with diagrams, because they understand pictures. Remember, they don't understand what you tell them, and you have to draw it for them, and they have to see what you mean. So draw a diagram for them in future. I think they might pick it up a little bit, well, at least briefly, because of course they'll forget it the next day. If they do absorb it, if they do understand what you've said, they won't absorb it, and if they absorb it, they won't comprehend it, and they certainly won't remember it the next day. But at least you might get a brief period while you're drawing the diagram that they sort of understand what you're saying.
Okay, continuing.
Entity relative to each other. So there's no contradiction there, Nora. Second point. Whilst having the definition of force on screen, Nora puts this comment. Riley thinks because he thinks we cannot observe the effect of an unknown force. So far, we cannot manipulate. He equates cause with that which one manipulates. Fallacy of false cause. Well, if we manipulate it, according to scientific method, if we manipulate your independent variable to prove the cause of an effect, with the egg, we know that when that egg is in a state of neutral buoyancy, if there is a force there, it's the net force of 0. But my assertion is that there's no force there at all.
Yeah, stop.
Right.
My point is, Riley, we can measure the pressure inside the glass vessel.
No, it's better than that, Gio. It's better than that. He's claiming there is no force at all being exerted by the egg. Let's take the egg. Let's put some scales underneath this jug with the egg in it, and then let's remove the egg. The force of the scales changed. Right. So the egg was exerting a force, wasn't it? It's not like it's not contributing. There is a net force there of 0, but there's still a force there. So if you take the egg out, the scales change. So it is exerting a force on the bottom of the jug, The jug is responding to that, and you can weigh it. Just insane.
Yeah, what I was about to say is, if Riley thinks that there's no force on the egg, what you can do is actually put a pressure sensor inside the fluid and check and see that the top of the fluid is actually pressing down on the egg, and also on the underside of the egg.
Yeah, definitely.
Hence why it's staying in the same place.
Yep.
But he's also claiming there are, that for there not to be any net forces on the egg, that means that the egg cannot be exerting any forces on anything else, presumably, and therefore it cannot be adding to the weight, when of course we can tell that it's doing that. So the only reason it's staying where it is, because therefore, in other words, we can establish that the egg is exerting a downward force. So what is stopping that egg, which we've established by putting it on the scales and removing it, is exerting a downward force? What is stopping it from moving downwards? And of course, it's because there's an opposing force, like the tug-of-war you were describing earlier, pushing in the other direction.
Also, here's a fun question for Riley. What's denser, an egg or water?
Well, and I think this case, actually, they've put salt in this, haven't they, to make the egg float, I think. So initially, I think the egg was
Well, you must be very careful here, Rumpus. It's possible that there's actually a density gradient inside that water vessel.
Yeah.
Because if you dissolve salt in there and you're just a little bit careful and don't stir it, then the salt is actually going to concentrate on the bottom of the vessel.
This is from a video in which they poured the salt in. So yeah, I agree with you. This is possible, but the basic point is that I think the egg was floating initially, and then they so it wasn't floating. What is one doing?
It still has a shell.
Yeah, but they changed it by pouring in salt.
Well, no, because that shouldn't matter if what Riley says is correct. If all that matters is relative density, then the egg should sink.
He's claiming here the egg presumably is the same density as this salty solution,
which it isn't, because the shell isn't.
Oh well, he presumably he's going to claim the average density of the.
But shouldn't then the shell remove itself from the egg?
Yes,
Well, presumably he would claim the forces holding the shell together presumably would stop that from happening. It's greater than the density forces, than the buoyancy forces, I suppose.
Yeah, obviously.
Well, he would claim that, so that's why it's presumably hanging in there. But yeah, so we can demonstrate there are forces going on here by just measuring what's going on, removing the egg or putting the egg on, or as Gio said, putting some sensors in the egg, and you can establish there are all sorts of forces going on. All sorts of forces. They're not zero forces, they're net forces.
Continuing.
Quality between the density of the egg equal to the density of the medium it's in. But what Nora says is he equates cause with that which one manipulates. Well, your independent variable is the variable that is manipulated by the researcher in an experiment. It is the presumed cause.
Stop. The reason he's talking about this again is because they hasn't mentioned it here, but I think in this experiment, this video, they actually poured the salt in. So I think he's claiming you can change the density of the medium, and therefore that is the cause, or his independent variable is how much salt you've poured in. He hasn't mentioned this, of course, but I think that's actually what he's trying to get at. I mean, I know it seems insane what he's saying here about you have the control over the density, but he actually means that that's because he's been pouring salt into it or not.
Yeah, exactly. You obviously do have the control over the density, but where's the connection from that to density is a force?
Yeah, I mean,
there's exactly no relation there.
Exactly, it's just gone off wildly into this quantum eraser dogma land where they prefer to live about independent dependent variables, and say it's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e., the thing that is the cause in his mind. Although, of course, he doesn't like the idea of any cause has more than one factor, because, of course, you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors, and he can't cope with that. Like Nathan doesn't understand that an effect is the result of more than one factor. And
yeah,
so
apparently he doesn't understand that an equation can contain more than two factors.
Yeah. Yes, more than one factor. No,
more than one factor actually.
Yeah, exactly right. So they basically just got wrapped up in this independent dependent variable, and they're trying to use it to prove everything because they can't cope with equations, or forces, or maths, or equations.
Yeah, to the casual spaceman, they actually claim that time cannot be an independent variable. That's just obviously completely idiotic.
Time is. I just read that after I heard them say that. I went and I researched that, and everywhere I see in any science journal, it says time is always the independent variable. It's always.
Yeah,
there's no way to make it the dependent variable.
Which is why you can eliminate it from being a factor in most experiments in many experiments by actually running all those experiments for the same time.
Right. Like I don't understand where they don't get that. Like in chemistry, and you're a chemist, so you can even expand upon this idea.
Yeah, for example.
I'm sure you have two different times where you take a measurement at one time and you say our prediction at a measurement at time t should be this based on what we get at time t prime or whatever. And
example. So during my master thesis, I worked with chiral organometallic catalysts, right? Basically, what they do is they accelerate a chemical reaction. Now, we actually wanted to find out how active these catalysts are, meaning how many molecules of starting material can they transform into how many molecules of product in a given set of time, right? Which gives you a certain rate. Now, the idea to compare two different catalysts would be, for example, which is what I did, just to run the experiments with the same concentrations of starting materials for the same time. Because if you run experiment A for 24 hours and you run experiment B for 24 hours, and you see that during those 24 hours, let's say catalyst A transforms everything, while catalyst B only transforms half of it, you can immediately see that catalyst A is better than catalyst B.
Yeah.
Right? Because if you wouldn't do those experiments for the same time, let's just say you would do experiment A for 24 hours and experiment B for 12 hours, or the other way around, the amount of information you could get out of there would be much smaller because you haven't eliminated that one independent variable yet. You didn't get rid of it in your equation by just setting it to the same in every experiment.
And presumably, Gio, you also run the experiments at a particular time. If you want to get so much precipitate or whatever, or so many product, you presumably can run the experiment for longer or shorter. You have control over how long that period
basically,
is.
that was the first step. First of all, you determine how good your catalyst is by just running the experiment for various sets of time.
Right.
And then, for example, let's just say after 24 hours, 99% or so of the starting material is converted. Then you can say, yeah, it makes no sense whatsoever to run it for 60 hours.
Right.
Because
but
obviously
you might get that extra 0.001%. That's important.
Micro, that's actually less than you have of mechanical losses during workup.
I know. That was...
It's especially at the small scales I did. My experiments usually had about a scale of 100 milligrams because the catalyst is expensive as fuck.
And yeah, we do the same in cell biology, like the same in terms of like doing experiments where we use the fact that time is that you can't change time.
Yeah,
so you might as well just
chemistry,
take advantage of that.
After you get your catalyst in chemistry, there's 3 steps. First of all, you run the experiments basically forever. And then you start manipulating the conditions, for example, temperature, solvent, for example, acid and base concentrations, whatever affects your stuff. When as soon as you found that optimal point, those optimal conditions, you then change the time. You try to reduce the time as much as possible. And then once you found that, basically you change your substrates to check on what different types of chemicals your catalyst is able to convert.
Yeah, I mean, time is also just a basic laws of motion. The distance you cover is proportional to the time and the velocity. You can control how long you do something for, and that determines the distance. I mean, it's so ridiculous to say that you can't control the time in the context of the thing you're trying to, the effect, which would be the distance you've covered, and your cause, which would be the speed, the two factors, which would be the time and the velocity you're going. I mean,
the only thing is that you don't control it in the same way you control other variables. Yeah, but because it changes by itself, you can take advantage of that.
Yeah, and you can remove it or add it into the context of whatever it is you're thinking about.
Easiest example ever. Have you guys ever boiled a potato?
Yes.
Okay, so when you boil your potato, what do? You throw it into the boiling water, and what do you do then?
No, you heat up the water.
Let's just start with
my process.
Boiling from the start.
I put the potato in the water, and then I slap my kid 6-7 times, and then I check on the potato, and then I go slap him 6-7 more times. I go check on the potato. Eventually, the potato gets done. It's based on how many times I slap my kid.
Okay.
Good independent variable there, right?
That's the point. Obviously, time is relevant for how, for the lack of a better word, doneness of that potato, right? If you just throw it in and then take it right back out again, it's gonna still be raw.
Depends on how hot the water is.
Yes, other factors. Yes.
Well, it's pressure. It's gonna be a 100 degrees Celsius.
But
if it's twice the pressure.
Can we wait? What if I'm autoclave? I use an autoclave to boil my potatoes.
There are other factors there, aren't there? More than one.
Micro, good luck opening that thing.
What if I'm on Mount Everest?
I think on Mount Everest you actually can't boil potatoes.
Thanks for explaining your joke.
What happens if you're in the middle of a black hole? I mean, they could go on and on all these factors.
Then there's no potato. Ha!
Well, anyway, this is such a simple experiment that everybody has done more or less voluntarily.
It's
especially
amazing.
If you're Irish.
I can't understand whether they're really stupid or they're just so wishing this to be the case. They're ignoring what they know from common sense or from explanations they have definitely received from people like ourselves. It's desperate stuff, but I don't quite understand whether it's just gross stupidity or they're on the edge of understanding it and they think, well, I'll go one way because it's more convenient, or
it's gross stupidity.
Yeah. Jesus. Yeah. Okay.
Also, Gio, I want to point out that actually, if you are Irish, it does actually depend on what time.
Because you're always boiling potatoes?
No, because there was a potato blight. So there weren't any potatoes. So time is a factor.
Yes, you only get certain opportunities to eat your potatoes. Right?
Yes.
Okay, scientific paper. Boiling potatoes doesn't work if it's 1849. Okay.
No, you can't boil potatoes without potatoes.
Oh, it's geographical specific as well. That's right. It's 1849 and in Ireland.
Yes.
Okay, anyway, we still got 1 minute 22 seconds to go. So
more potato, garbage.
She says he equates cause with that which one manipulates. Unfortunately, Nora, it complies with scientific method and is the cause of the effect. So on the one hand, if you're going to claim that there's a force there, then you're going to have to demonstrate that force by wiggling it. That's the reason why we have the requirement. But
stop. So he doesn't understand. He doesn't understand that there's devices we can use to measure forces directly.
Wait, what does he mean by wiggling it?
Right, he's got this thing now where they talk about varying the independent variable, and he calls that wiggling it. That's his little fun phrase he uses to describe manipulating the independent variable.
I want to punch something.
Yeah.
Preferably him.
Yeah, I think so. That's definitely, I think that's,
Micro, you shouldn't punch him. I'm not in favor of animal cruelty.
or child cruelty. Also, if I break open his skull, the vacuum inside it might destroy the Earth.
That's not a vacuum. That's just magnetism.
It's the relative density between the inside of his head.
Again, he hasn't mentioned it again, but I think he's again saying he's manipulating the density of the medium, and that's causing the egg to change behavior. So because he can't understand, as I was describing earlier, he only believes there's only ever one cause for anything. Only ever one. They never accept things like the Cavendish experiment, where you've got two masses and the distance between the masses. They never accept an equation. They call it, I can't remember now, there's a name for experiments with more than one variable. I can't remember, it's multivariable something or other. And because he thinks because he's got one cause, this density, that's it. There's no other cause. Therefore, they can't cope with the concept of there being more than one factor. And so because they found one factor that causes the egg to change its position, therefore they believe that to be the single only cause of it changing. And therefore they think they found it. And therefore they say, we can manipulate this, we can manipulate density, therefore that is the cause, and there can be no other, so that's only to do with relative density.
So
that's their argument, I think.
Rumpus, are you saying that math is too complicated for flat earthers?
I am saying that very much so, yes. Yeah, anything involving more than one variable on the right-hand side of an equation is not allowed.
Yeah, on whatever side of the equation, obviously you can rearrange it the way you want.
Yes.
I was about to say, what about if they have more than 3 variables underneath division lines?
I mean, just for example, take a look at the real gas law, right? PV equals nRT.
Yeah.
What about the fake gas law?
Would that be too complicated for a flat earther to understand?
Yes. Have you seen? They already have problems understanding pressure gradients.
I was just about to say how they don't understand that at all, because then they would have to explain a pressure gradient.
They don't even understand what pressure is. I've asked many of them the difference between pressure and force, and about 80% of them don't know the difference. I mean, and of course we get things like Nathan saying, they don't understand that in a room, for instance, how you measure the pressure. They get confused with all this pressure gradient stuff about having an area. They think you've got to have an area exerting the pressure. They don't understand the difference between the thing that measures pressure, i.e. in your living room, how do you measure the pressure in your living room? The fact that's got to have a surface area from which to press, and the fact that the thing that generates the pressure doesn't need to have an area you need to worry about. You just, the gravitational force is acting on all the molecules, and the effect, the height of the column of air above you.
Well, Nathan Thompson said that we have to shake up spray cans because there's a pressure gradient on the inside of them.
Really?
What?
Yeah.
Jesus.
Yeah.
I mean, how can these people be so? I mean, this is what comes when your imagination is not constrained by a knowledge of physics or common sense or how the world works. And so
what happens when all you have is imagination and nothing else.
Michael, you bloody stole my punchline there. Yes, exactly right.
I mean, it allows for things like the movie The Wizard of Oz and Superman to exist. So, yes. I mean, so there's a need for just pure imagination, but it's not.
No, because in order to make those, you also need to know things about the real world, so you can actually make the movies.
Yeah, making the movie is one thing, but what you just show in the movie is another. Yeah, so the point is they're unconstrained, so that I'm always stunned as to what they think up, and it's because when you're dealing with people who understand reality and physics and chemistry and whatever, and reason and logic, you realise you're very constrained about the ideas you can have, and when you have no constraints on logic and reason and evidence, you can come up with all sorts of stuff that I would never have ever thought possible, and they just have an unlimited resource of this stuff because they're not constrained by sense.
You need to find a way to use it to power the world.
That's the point. They just don't know what to do with the data set.
They can't absorb information. They can't process information. They can't regurgitate information. They can't do anything, basically. They're cognitively retarded, basically.
Well, it's almost they come from a stance that we alter science to fit our model. So therefore, they alter their understanding of science to fit their model. It's never going to be, they're never going to willfully accept an incorrect explanation or an incorrect answer to something if that incorrect answer violates their world belief.
Yeah, their wishes. Yeah,
they essentially think that we operate the same way that they do.
Yes.
Yeah.
They extrapolate their weaknesses and their
projection
fuck up onto us. Yeah.
Yes. Now here's the thing, and this I said this with Simon and Dan the other day. This is why our community is so much stronger than their community, because we're not having competing ideas. You know, we don't for the flat earth, you have flat earthers that believe that it's relative density, and you have flat earthers that believe it's something else. You have flat earthers that think there's a dome, then you have flat earthers that think it's an infinite plane. There's so many different factions of flat earth that even when they're trying to disagree with us, they by default are disagreeing with themselves as well. So they have smaller and more unique communities, and it shows that all of them, like either one of them are right or all of us are right.
Yeah,
that's the only case.
Imagine though the task that's before them. Imagine taking on the whole body of human knowledge and scientific institutions and the hundreds of thousands of people who generate this knowledge, and you just simply taking it on with wishful thinking. It'd be such a challenge. I would think, whereas we tend to have a rather humble opinion that whatever we know, there's bound to be someone who's written down something somewhere in a document somewhere or in a paper somewhere that will tell us what we need to know. We just simply weren't aware of it because we know that the body of human knowledge is absolutely vast, and we're just simply struggling to wander around it amongst other people. I mean, obviously people like Geo and Micro and finding out little bits of new information, but the vast amount of knowledge they know is vastly intimidating and greater than your own personal knowledge. So they must, I suppose it's Dunning-Kruger, isn't it? They've got this vast confidence in their own abilities because they don't understand, they don't have that knowledge, and they think they can take it all on. But if I was thinking, oh my God, I want to take on, I don't know, Sean Carroll, Einstein, or Newton or something, think I can come up with something different or better, I can invalidate this. It'd be terrifying for me. So I can obviously, then it's really easy for me to then go off and just go and look at what Newton, Einstein, or whatever has done, and then just regurgitate it. And that, well, obviously understanding it's a bit tricky, but once you've got that bit, you've got such a battery of information and weapons to use on these people. Well, of course, they don't realise, because they're Dunning-Kruger, they don't realise what the challenge they're taking on.
Well, it's just like the guy that we're covering right now with Meet and Fight the Flat Earth. We got a Dunning-Kruger specialist in this guy, J.M. Truth, and he continuously says things that are non-stop scientifically wrong. And last night, he literally said, me and Nathan Thompson, we're scientists. And the guy goes, what kind of scientist are you? He goes, well, I'm a physicist amongst other things.
Yeah, bullshit.
Really?
That is Dunning-Kruger. You take the top of Mount Stupid and see how far away you have to go in knowledge to get there, and that makes it easy to be an expert in every fucking field when you're suffering from Dunning-Kruger. It's because all you have to do is have the first three an opinion based on the intro paragraph of a science book. I know this whole science book.
How much does the horizon drop from the top of Mount Stupid?
8 inches per mile squared.
Yep.
He literally wears a shirt. He wore a shirt on last night's show on the Nathan Thompson show, and he stood up and showed it. And it's like, have you ever even thought to plot that out? You claim to be a mathematician. You claim to be a physicist. You claim all these things. 8 inches per mile squared. Plot that out. Tell me what shape that makes. Does it make a sphere? No, it doesn't. Why? Because it's a fucking parabola. That's the peak of stupidity right there to show that you don't know what you're fucking talking about is by wearing a shirt like that and then saying the stupid shit that you say all day long.
That's just a circle with an erection.
Right. Yes.
Yeah, I was always reluctant to use that 8 miles. When I first met it, I thought, what is this bollocks? That doesn't describe a circle. But of course, it's for all the purposes that we use it, looking over about sort of 200 or 300 miles, it's fantastically accurate. But of course, it doesn't do the whole Earth.
Nope.
I was amazed when I saw how accurate that was. It's just incredible. But it only works for a couple hundred miles. After that, it starts to go, if you draw a graph of it, it starts to go a bit bonkers, obviously, for a bit, and certainly can't cope with a few thousand miles.
Yeah, in that case, just use the GeoGebra model I made.
Yeah, do that.
Because
I think we tested that, Rumpus, didn't we? And it fit to a centimeter?
Yes, it was pretty hot. Yes, it was. Yes. That's right. Your one was actually remarkably accurate.
I need to start incorporating that in my videos.
Sure. I'm just gonna send it to you later when I found it.
More garbage?
It's buried somewhere deep inside my hard drive.
More garbage.
Yeah, 1 minute to go. Let's just continue and finish this.
Because we did wiggle the medium relative to the egg, that makes it the presumed cause, and then when we wiggle it, we establish it. That proves the cause and effect relationship.
No.
It
doesn't.
Well, again, he's claiming again, he's pouring in this salt or something, and it causes the egg to move up and down. So he's claiming again by pouring in salt, that's the an independent variable, and it's causing. I mean, I'm not quite sure what the actual effect is. Yeah, I'm not quite sure what actually is their dependent variable. What is it he's saying is varied? The position of the egg? Is he saying that's his dependent variable? The height and thing, or the?
I think yeah, basically whether the egg sinks or floats.
So that's a rather old dependent variable.
He cannot use that experiment to show that. All he can show is that he gets that there's a correlation between that experiment does not prove causation. He has no idea whether or not it could also be, because he's also doing other things. The fact that the moment he adds salt to it, there's also now more mass. For example, that's one thing in the glass. He hasn't accounted for that. He cannot show that this is a causal relationship with this. Also, he said that he proved something, which means he really doesn't understand what the fuck he's talking about.
Hey guys, hey Rumpus.
Yep.
I'd like to correct something you guys said about this 8 inches per mile squared. And yes, it does describe a parabola, but it does perfectly describe a sphere. It depends upon how you choose your coordinate system. I did a video on this because I heard this very same thing coming out of flat earthers saying, how can 8 inches per mile squared describe the surface of the sphere? Because it is not the equation for a surface of a sphere, but it is the equation for a surface of the sphere. If you choose your coordinate system, remember, if you choose your coordinate system properly, remember to describe the surface of a sphere, you're choosing a coordinate system at the center of the sphere where you have x squared plus y squared plus z squared equals the radius squared. That is with respect to a coordinate system at the center of the sphere. But if you now go to a tangent to the surface of the sphere and do a coordinate transformation, you will find that equation end up being a parabolic equation. It does describe the surface of the sphere. Now, the accuracy, if you choose the chord distance from the observer to the target rather than the arc length distance, that equation, 8 inches per mile squared, is exact for any distance. It is exact. Where you get the approximation is where you try to approximate the chord distance by the arc length distance on the surface. Then you pick up an error if you start going out thousands of miles. But for any distance along the surface of around 1,400 miles or less, the error is so insignificant as you can ignore it. But go watch my video on that, and I do the coordinate transformations, and I show you where the equation for the surface of the sphere becomes the equation of a parabola if you choose your coordinate system from a tangent line to the surface rather than starting at the center of the surface, center of the sphere.
Okay, George, I'll watch that. Sounds interesting.
Yeah. Anyway, yeah, I just wanted to get that straight because that I heard flat earthers saying that how can 8 inches per mile squared describe the surface of the sphere when it's a parabolic equation, but it is the proper equation if you choose your coordinate system from the tangent line rather than from the center of the sphere. Anyway, catch you later.
Okay, George, thanks.
Okay, thank you for the correction. I'm gonna check out your video as well. Can you maybe send me the link to it? So yeah, I can link it down in the description of the video.
Yeah, I'll find it and I'll put it in the chat there.
Okay, thank you very much.
Right, so we're back to and yes, where
were we?
Well, right. The point is, he's thinking that because he's getting a Micro was just talking about adding in the mass of the salt, and of course that's what causes it to happen. That is actually adding the mass, but of course it could be causing a chemical reaction or God knows what. But Micro's point is that it's changing the mass, which actually is the change of is the cause of this thing. But he doesn't describe what the dependent variable is in this thing. He says, okay, well, presumably it's the position of the egg, which obviously stops when it reaches the top. So it's not a very good dependent variable, I have to say. It's a pretty crappy dependent pair. Is just a sort of consequence. Obviously, that's the other thing I don't understand is that they don't understand chains of independent variables and dependent variables. For instance, when we talk about the Cavendish experiment, you can't change gravity. You can change the gravitational force, but you can't change the gravitational rule by adding a bit more mass, and then that causes the attraction to be increased, which causes the torsion bar to be moved, and so you get a chain of dependent things. And what they don't understand is that one independent variable causing a dependent variable becomes the independent variable for another cause. So if you've got several things down the chain, like the torsion movement in the Cavendish experiment, that's several layers down the chain of independent variables causing a dependent variable, and then that becoming an independent variable causes another dependent variable. But that chain is completely beyond them, of course.
So I'd come back after an hour of eating and Rumpus is still talking?
No, he's talking again. Welcome back, Sly. How are you?
You didn't get very far in the video now, did you?
Oh, we're nearly finished.
We're almost finished.
We're nearly finished.
Uh-huh. Yeah. Okay. What'd I miss, or besides everything?
Everything.
Yeah.
Nothing. No. Basically, we've got through quite a lot actually of different things, talking about black holes and independent. Well, the basic thing here is, perhaps I haven't seen this. He's pouring in salt into a container jug with a egg in it, and he's moving it around, and he's therefore claiming that we
did that in high school.
Yeah, because he doesn't understand that you can have more than one factor. Basically, only one thing can be on the right hand side of an equation causing an effect. He thinks that because you've found one thing that causes the egg to move around, that can be the only cause, and therefore can't be gravity. Gravity can't be involved, because he and the Nathan Quantum Razor crew only believe there's ever only one cause for something. You can't have multiple factors, and so because of that, because he's now using this argument of saying, I found the independent thing, therefore there can't be anything else. It can't be gravity, because I have found that the independent variable is the density of the salt that I've poured in, or the amount of salt I poured in.
Now, one thing I'd like to say, though, is that even though you can have multiple contributing factors, they all create that. Now, this might start an argument, but they all end up creating a cause.
They create the effect.
Right. But what I'm saying is, you can have a lot of factors together. it's
Yes,
not just,
obviously the cause is the
sum of those factors. That
Right.
You have.
Some.
Yeah, I shouldn't use some. Yeah, okay.
The combined conditions in which the
Right,
experiment is
exactly.
happening.
right. Like, I mean, you can't have a hot air balloon just because you have a big bag of vinyl. There's a couple of things that are going on that actually have to happen for that hot air balloon to go up. For just as an example, I don't know if that's a very good example.
That's why I broke both.
Well,
my
you need an
legs.
atmosphere. See, you need to know the relative density of your hot air balloon versus the density of thing versus gravity. So there are about 3 or 4 factors that determine if you want your dependent variable to be how high does it go up or how quickly does it go up.
Yeah,
You need about 4 or 5 factors in there on that create the cause of whether or not the thing, your dependent variable, which is say your height.
Right.
So you do have cause and effect.
So ultimately, all the conditions of a situation can contribute to an end result, and that would that entire list of conditions, no matter how long it is, becomes the cause.
It's more normally to call them factors. So the factors that create the effect.
Well, we can say factors. We can say conditions.
You can say, well, conditions doesn't. No, because conditions can be fixed. Factors imply you can vary them. So conditions could be.
I'm not going to argue with you on the terminology.
We all know what we mean. Like,
do we? Okay, good. So basically, this is the point. The key point is that he believes there's only one factor, only one variable that can be causing an effect, and therefore, because he's found one, i.e., the density of the salt that he's poured in, he believes therefore he can eliminate as one part of his reasoning that therefore there's no gravitational effect, because you only ever have one factor, one cause for an effect. That's his reasoning.
By adding to the salt to the water, that changes a couple of things, so therefore it changes the factors involved.
There's one, but the key thing is he believes there only can be one, therefore there can't be gravity involved. That's his reasoning. Although he doesn't explicitly say it as I've done, that is effectively his line of thinking.
Hey, Riley, why don't you add electricity to the water? So
yeah, current, yes.
And then stick your hand in it.
Nah, we all know that the best test for electricity is the tongue. Come on now.
Actually,
that's why Geo talks so funny.
Oh, what the fuck? That's not the rule. That's completely false. Okay, 50 seconds to go. Let's continue.
That's a good point, Gio. You're going to have to test the 12 volts on that battery you're doing for Slide's experiment, aren't you?
Oh, I have a better idea to test those. I
have
a device for it. Either my multimeter or, well, I think the charging device actually
got to be long enough to reach the 2 poles, man.
The charging device I have actually has a little counter on.
Wait, I thought you were using more than one pole. Like, I thought you had multiple poles all along the channel.
Oh, for fuck's sake.
Also, who are these poles? Why do you have to use people? Why can't you just?
Yeah, I have to apologize. When I saw that sign, hit the pole and win a prize. That was a mistake.
Yeah,
I'm sorry.
To Germans, that means something different.
Yeah.
Anyway,
50 seconds. Let's continue.
Hold on. To everybody in the chat, if you really want to drive Gary nuts, just ignore him.
Yeah.
That's when the caps posts start coming out.
Well, it's like he actually just said, typed a few minutes ago that once apparently there was a loss in his family, and sorry to hear that, mate.
Yeah, which is sad. Yeah,
obviously. But he said that after this period is over, he will actually be ready to join in the future. Let me see if I find the exact quote.
What, join the hangout?
Join one hangout. There we go. So a few minutes ago, quote, "I'm waiting at the warehouse for delivery. It will be here in any minute, and then I have to go because my mother-in-law died yesterday at my home. But I'm ready to do it pretty soon." So the last sentence, "I'm ready to do it pretty soon." I think that means that he wants to join in the future sometime.
Well, on the human side, sad that you had
sorry about that
and all this, but what do you call it? On the YouTube and back to the subject side, Gary's words don't mean a whole lot to me.
Yeah, but anyway, if you're saying something that is demonstrably false, I would expect you to defend that.
Oh yeah, well, that's something.
Anyway, 50 seconds. Let's continue.
The cause in this experiment, the manipulation of the medium, that is what caused the displacement. So if Nora or Bob or anybody else that disagrees thinks that there's a force in this thing when the thing that we manipulate is the medium, you are literally going against what scientific method states. That's worse than failing to address it in the first place by just not manipulating it. If you're saying that
Gio, you are a chemical student on your way to becoming a big name in the chemistry industry.
Hopefully.
So now using, I think it's what is it? The preservation, Newton's preservation of energy or preservation of mass. By adding salt to the water, you are not manipulating the water itself because the salt actually doesn't disappear; it just dissolves in the fluid, right?
Yes, exactly.
Right.
Well,
so
that
you're
is
not.
You do,
manipulate the medium. It doesn't
however,
become part of the
manipulate the
medium.
density of the fluid to a certain degree.
The medium, yeah.
Well, it manipulates the density, but it's by adding salt to it. It doesn't actually manipulate the water itself.
Well, things dissolved in water. I think we call that.
In a way, it does because it actually changes certain facts about the fluid. For example, the conductivity.
Okay, well, conductivity and all that, but that has to do with the spaces between the molecules, though, right?
No.
Basically, it has something to do with the fact that the ions are not contained in a solid block in the salt anymore. They are pretty much free to move within the fluid, which means that if you add an electrode on one side of the fluid, the ions will be attracted to that or repelled by that, depending on the.
Well, I guess what I'm trying to say is that when you add salt to water, you are not changing the water; you are making salt water.
Well, in that case,
that's just a weird way to phrase its lie.
Yeah, I mean,
I understand. I think I understand what you mean.
Yeah, but that's like saying then the solutions aren't any different. You haven't changed the water. I think we refer to the net sum of the thing, the solution itself, with the combination of water and the solute.
Right. That's what I'm saying. Salt water. You have made salt water in this sense.
Yeah.
Oh,
so,
okay.
But what's the point?
Just like if I put Kool-Aid into water, I've made Kool-Aid.
Yes, that's called an abomination, and you shouldn't do that.
Shut up.
No, that's called an efficient way of getting rid of your followers.
Okay. But what I'm saying is that he's not actually manipulating the water. He's actually changing it from what it was to what it is now, which is a denser solution, right?
Well, yeah, he does call it the medium, though. So you have changed the medium.
Yeah, but you changed it to
the egg.
You haven't manipulated the medium. You've actually changed it to a new medium.
Yeah. Whether you use salt water with a density of, I don't know, 1.05 or whatever grams per cubic centimeter, or whether you're using a different fluid wouldn't make any difference in this experiment.
Yeah, but that's kind of where I was going with this, is that, if I didn't catch all of what he said, prior to this, and by the way, this is not his footage. This is Phuket Bird's footage.
Yeah.
And what do you call it? Because I remember this video.
Yeah.
But he, I guess what I'm saying is that by adding salt to the water, you are not, what do you call it? You are not, you're not manipulating that medium. You have created a new medium.
Well, it already has lots of salt dissolved in it.
Yeah, in a way.
So you've added the constituents already exist there, and you've increased them.
Mm-hmm. And so in that case, saying that adding salt to water, what do you call it, makes this egg float, which, those are the conditions, but you're actually creating a new solution, so it's not the same, it's changing the medium. It's not actually manipulating the medium. You understand what I'm saying?
I don't actually get what your point is.
Change and manipulate sound the same to me.
Okay, I think what you're trying to say is there's a difference between having the water and then doing something to the water that makes the water change, and then adding the like, say, just hypothetical, having the water molecules fall apart. There's a difference between that and adding something to the solution.
Right.
Yeah, I think what they're trying to say is that by they're trying to make the correlation that by adding the extra salt, you're going from an apple to an orange, when you're not really going from an apple to an orange. You're just manipulating the apple.
Right, because what he's trying to do is he's trying to change the what he's effectively doing is actually changing the density of the density of the medium, but not because he has added salt making the water different. He has now added salt, and now it is a salt water solution.
Basically, all that he's doing is having the egg immersed into a solution of different densities, whether that's water with salt in it, which is slightly denser than distilled water, for example, or whether that's another solution. For example, a sugar solution would have the same effect as long as the densities are identical.
Right.
Right, and so
a sugar solution in sugar dissolved in water.
So, and basically, what I guess all I'm really trying to get at here is that if he's trying to say that he's actually making the water more dense, he's not. He's actually making salt water, which is more dense.
Yeah, well, you're saying the water molecules have not been changed by that. But yes, and in most cases when water is not manipulated, you don't change the water molecules unless you have a chemical reaction.
You kind of do change the water molecules.
It ionizes a bit more, does it? Yeah.
Because a bunch of them will orientate themselves in such a way that they actually enclose the individual ions.
Yeah, they jiggle around a slightly different way, yes. But they're not, their orientation might change, but they're not chemically changed.
Yeah, that's also not
well,
really
okay, so they might ionize a bit.
There are slight differences, because basically the electronic properties of individual water molecules that have direct contact with the ions are
right. So that's exactly what I was getting at, is that adding salt to water is not salt and water, it is salt water.
Yeah.
And so therefore the solution is not salt and water, it is now salt water. So you have not actually the medium has actually changed.
I thought you were saying it hadn't changed.
No.
Oh, okay. I'm sure at one point you were claiming
it's a different medium.
Yes,
in a different
meaning. Whether they're using water or with salt in it, or whether they're using gasoline with whatever in it to arrive at the same density, it wouldn't make a fucking difference.
No.
It wouldn't make it more metal.
Yeah, that's true.
Should we move on before we get...
Yes.
26 seconds.
That the manipulation of the medium around the egg somehow is a force, then you're literally pissing in the face of scientific method.
In the alternative.
What?
Right, because he's using independent variables, he thinks he's doing a scientific experiment.
Back up the whole sentence.
I need to say that again, because I think I misunderstood him in a way.
Manipulation of the medium around the egg somehow is a force, and you're literally pissing in the face of scientific method.
You need to go back to about 6 minutes, man.
What?
Because you still cut it off.
Okay, let's start at 6 minutes and play this once again. So everybody shut the fuck up until we arrive at 6:20.
Literally going against what scientific method states. That's worse than failing to address it in the first place by just not manipulating it. If you're going to claim that the manipulation of the medium around the egg somehow is a force, then you're literally pissing in the face of scientific method.
In the alternative.
Actually, he's explaining it perfectly right there, that now that the water is more dense around it, gravity is hitting it the same way it's hitting the egg, and therefore you get the equilibrium there.
I'm not sure he knew what the hell he was saying.
No. He's trying to say that well, if I understood it correctly, which is very likely that I might not have, because it's Riley.
That's right, because we have to do a lot of work with these people. We have to try and understand what they mean, because they cannot express what they mean properly. So we have to do a hell of a lot of work to try and turn into some sort of sense that we can then argue against.
Play the 6 minute one more time.
I love how we have to break down their one sentence.
That's all.
Get an understanding of what they mean.
Okay, playing again from 6 minutes. Let's go.
Scientific method states that's worse than failing to address it in the first place by just not manipulating it. If you're going to claim that the manipulation of the medium around the egg somehow is a force, then you're literally pissing in the face of scientific method.
Okay. No one is claiming that changing adding the salt is a force.
No, that creates equal force because you have now got the density
equilibrium. Like no one is saying that adding salt is a force.
Yeah, no.
What's happening there is that after the salt dissolves, basically because the average density rises a little bit, the water will be attracted towards the planet more per unit volume.
Right. That's pretty simple stuff. So nobody said it was a force. You have basically you've stopped buoyancy because gravity is hitting the salt water now as hard as at an equal amount as it's hitting the egg. That's all.
Yep. Let's continue.
16 seconds. Okay. Let's run this all the way to the end.
Density becomes the force. That means that Rumpus, all those times when he told us that density is not a force, weight is a force, that would mean that Rumpus has been wrong all that time. And scientific method proves it.
Wait a minute, he just contradicted himself. Play the 6 minute all the way through.
Okay.
He contradicted himself because he said density is not a force because of manipulation, but then he just said that density is the force. Play the whole thing.
Okay, 6 minutes all the way to the end, right?
Yeah.
What scientific method states that's worse than failing to address it in the first place by just not manipulating it. If you're going to claim that the manipulation of the medium around the egg somehow is the force, and you're literally pissing in the face of scientific method.
Okay, stop.
In the alternative.
He's saying manipulating, if you're going to claim that manipulating the medium around it is a force, then then you're wrong. Okay, now nobody's saying that manipulating the medium is a force.
That's what Micro said earlier, yeah.
All right, now let it go further.
This
is where he contradicts himself.
Density becomes the force. That means
which is manipulating the damn medium.
Yeah, you're right. He's contradicting himself.
He just contradicted himself.
Yeah. What a dumbass.
He's calling
look at the title
for saying
the title. Density is a demonstrable force in the scientific method.
Is it possible that that's a new record? That he contradicted himself within 4 seconds?
I mean, he literally said that if you think changing the density, manipulating the density of a medium is a force, then you're wrong. You're pissing something, whatever he said. Yeah, but then he turned around and he said, then density is the force.
Yeah, he did do
that. Is a direct contradiction to either way you look at it.
So let's just note this record for fastest self-contradiction of Riley so far, at least as far as I'm aware.
Yeah, the question is though, did he mean what he said? This is the thing. These people are so stupid. They say things they don't mean, and they'll say, "Oh, well, I didn't mean that," or they think you're in their head, and that they've got this other issue. They think it's in the context of them thinking something, and you've got to somehow understand. This is why we do all this work to try what they're thinking, because they do not express it. They assume that you're inside their head and understanding what they're saying. And so you'll probably find that he's saying, "Oh, well, the second part of that sentence, then the former part, he meant one sort of thing of force, and the second part he meant another sort of force." So it's a case of this being stupid, and he probably didn't mean what he said, but who knows? Because he's
the only thing in his head is white noise. Okay. Well,
yeah, at what frequency?
No idea.
Like white noise doesn't
no, it has all the frequencies.
Yes. Well said, Micro.
That was actually an audio joke.
Micro, actually, any type of noise has all frequencies, but the energy, basically the amount of energy per frequency is different.
Okay, fair enough. That's.
And if you get close enough to that white noise, then hands come out of the television. I saw a movie.
I'm not. You think the energy? So you think the energy is not universal across all frequencies, then, Jew?
Yeah. For example, white noise. The amount of energy is identical at all frequencies.
Oh, so right. So it is identical at all frequencies, right? You said it wasn't.
But there's not only white noise.
Oh yeah, there's green noise and the other red noise. Yeah.
And basically the energy curves that describe how much energy is found in every single frequency.
Right, so for white noise, the energy is consistent across all
for white noise.
And then you have brown noise, where the energy levels these frequency is adapted so that it fits the sensitivity to that frequency of the human ear.
And it stinks up the room.
Yes.
Is there purple noise?
Well, I
It's
don't.
buzzing, isn't it?
I mean, purple noise would presumably be like a very low frequency and a very high frequency together. I mean, that's why we made purple light.
That's good point. Good point. Yeah, magenta. Yeah, it's a good point.
If, for example, George, I'm sorry, George, I can't pronounce your family name.
Natiuk.
Natiuk. Okay.
Just take the H off.
That pink noise equals equal energy per octave, for example.
Yes.
Okay, 12 seconds.
We can do this.
God damn it, Micro. Now I have to wind it back 1 second.
We've already passed this part. We just
we actually have it. This way, he calls me a liar.
Just fucking play.
Okay, then
just play it,
for the last seconds.
All those times when he told us that density is not a force, weight is a force. That would mean that Rumpus has been wrong all that time. And scientific method proves it.
He just reaffirmed that density was a force by his belief. That's his exact
look at the title.
What he said right there.
Yeah, so the title.
So at
density,
607,
yeah, exactly. I didn't even read that. Yes, exactly.
Yeah. So when he says at 60 something or 607 or whatever, when he says that changing the density of the medium is a force.
If we claim that, you're talking bollocks. Yeah.
Then you're talking piss or something like that.
Yeah.
He just claimed himself as talking piss or whatever his insult was.
Yeah.
Fucking moron.
Yeah, I've got a diagram of actually how buoyancy. I've got when I've been waiting in the wings here that I haven't got around the actual how buoyancy works. I thought we have to deal with actually what actually happens.
No, he's too stupid. It's stupid for you to even get to that.
Yeah, I've got that right. This is actually what the buoyancy is all about.
Wait a second. I'm not showing you yet. There we go. Now you can talk.
Right. So here we have an egg in the in our medium, and it displaces over here on the right hand side. Hopefully you can see that the water displaced by the object. The Archimedes principle says that the force of the displaced water downwards is that weight, and the buoyancy force is the opposite of that. So there's the weight of this displaced liquid. The buoyancy force is the opposite of that, and so your egg or whatever it is you've got in here is actually subjected to that buoyancy force. And if the egg and the let's just deal with what the force is of. That force is the mass of the liquid displaced, which is of course FW here, which is the weight of the water. And if you work that as that's simply the mass of the water times little g. And that, of course, if you know the density, down here the right hand side, down the 5 here, the force that exerts, the downward force of the water that's displaced, is the volume times the density of water times little g. That is the force downwards. Archimedes' principle says that the buoyancy force exerted on something that's displaced in that water is the opposite of that. So it's equal to the opposite. I should have put a minus on that, actually. Minus v 0 w p density. That is not a p, that's a rho g. So the buoyancy force, and the reason it doesn't move anywhere when they're equal, is because this neutral buoyancy condition over the left-hand side is the net. So okay, there's a net force on the object here. Fn on the object's net force is equal to the gravitational. I may have mentioned the gravitational force. The gravitational force of the thing of your egg, of course, is equal to its density times its volume, which is its mass times little g. So there we've got the force of the weight. The weight of an object is its force, as we established earlier, and that's equal to its density. And then so you equate the two. The net force on the object is the weight of the object that's in the that's displaced the medium, and then in the weight of the water. In the case of water, that's what the little w is. So the force of the gravitational force on the object is at FO, and the little w is water. So that's the buoyancy force is the -1. So the net force on the object is this minus that, and as we've established that that's dependent on the mass of both times little g and the volume. So if you know if they've got the same, of course they've got the same volume, which makes everything very easy because you displace the same volume of the object. You'll stick your egg or whatever displaces exactly the same volume. So you then end up with this equation. So the net force is, if you equate these two here, down here and down here. So I've got here is the force on the object. Here's the force of the displaced water. I've just equated them. So the net force is this equation here. You can eliminate the little g. Sorry, you factor out little g in the volume, and you end up with this equation here. Here is the net force on an object in a medium. Now it could be the net force is up or down, And of course,
basically, that's where you see that when those two densities are identical, the net force becomes 0.
Exactly, and that's what happens down here. The next paragraph is exactly that. Neutral buoyancy is when the stuff in the brackets becomes 0, and that, of course, means that the density is the same. But this is what Riley and co. cannot do. They cannot say, put a little force meter on here and say, well, okay, let's not have the neutral condition. So we can predict with this equation, but it has to involve little g of what force meter would show in this position.
Now here's the thing. Now I'm going to take this out of the university version. I'm going to put it into the middle school version.
That actually is the middle school version there, Sly.
I don't recognize half that shit. But
it has been a while since you were in middle school.
Can I have 10 more seconds, please, just before that? You can weigh how much this egg is by putting some little scales on here, and you can find that it has a net force, and this particular case obviously can only measure force down. And so from this equation here, which includes little g and the volume, you can work out and predict what the force meter will show. Nothing that Riley can do when he just has relative density can do that. He doesn't have an equation like this one over here, the net force on the object. He doesn't have that equation. So we can say, using this equation, we can predict exactly what the force meter will show, and it has to involve little g and the density and the volume. And of course, the other point is making here, so there are 3 ways you can actually make neutral buoyancy. You can make any one of these factors 0. You can make g 0, which is what happens on the vomit comet. You can make the volume 0, i.e. you haven't got an object, or the densities are the same. All those 3 conditions would cause the net force to be 0. But the key point is he cannot, when they're not neutral buoyancy case, he cannot predict with any equation he's got, predict what the force is. And you can see it's a result of 3 things. And so that's something they can't cope with. They cannot only believe in one variable.
Rumpus, your 10 seconds are over.
Yeah. Okay, all right.
You were at approximately 1 minute. Just something I want to say very quickly. This is something that flat earthers never do. They never give an alternative mathematical model to actually describe anything.
Yeah, exactly.
So
right.
if this is actually a challenge to flat earthers. If you come up with a page like this that actually describes all the phenomena, which does not include a factor g at the end, for example, then you would maybe have a point. Right? If you could describe the phenomena that we have without actually involving g,
you would have at least the beginning of something.
Yeah, you would have the beginning of something, exactly. You would maybe have an alternative explanation. However, this is something that flat earthers cannot do because we know that g is a thing.
More garbage.
I mean, simply put, in the Archimedes principle is that once you make the liquid, once you increase the density of the liquid, or the solution, better said, once you increase the density of that to equal the same amount of weight per volume of the object that you're trying to submerge, it equalizes. I mean, that's why you put salt in there, because of that. And that's why gravity has something to do with this. What do you call it? Now, I don't know if Riley would ever do this, but Riley probably needs to realize that what he also does is that when that salt gets put in there, it adds the same amount of weight as that salt was when it was standing by itself. So it's oh god,
more garbage.
Well, that was the video was over.
We finished the garbage.
Why are we still talking?
Well, because I wanted to give the conclusion as to how it actually works. When he said that I was wrong when I said that that claiming the weight was a force and that forces were involved, and his claim that density is a force. Well, I've already demonstrated that several ways. That density isn't a force. It doesn't have the right dimensions. It doesn't have direction. And it can't account for the force exerted by weighing on it. So we've shown that
I put pennies into an egg, and they're far more dense than water, but yet I made it float. So I mean, it's pretty simple stuff.
Well, if we're done with the video, I'm gonna head out. So.
Okay, then let's do it in the good old Red's rhetoric way, I guess. But before we do, is there anything you guys want to say about this topic? Team Skeptic, you have been very silent for the last, 20 minutes or something.
Well, he said.
Yeah, I've been taking care of a few things in the background, but I've been listening in the last part. I mean, there's not really anything to add. They're wrong and we're right. So I mean, everything was explained fairly elementary that even a 9-year-old could get. So I don't understand where the flat earthers are going to fall off. I mean, they have about 4 or 5 more years of intelligence to reach the 9-year-old level. So maybe in about 4 or 5 years they'll go back and watch this video and go, oh yeah, that was a great point they made.
Are we still going to be doing this in 4 to 5 years?
I hope not.
Yeah,
I don't know. Maybe.
This is the key thing. We are replacing the education, as Team Skeptic said, we are replacing the education they've missed out in their early teens. And you find this throughout. Whenever we're doing something, you suddenly discover you're just fixing the things that teachers didn't do for them when they were about sort of 11, 12, 13.
Yeah, but
Rumpus not necessarily. Maybe they suffered some serious brain injury afterwards.
Yeah, but did it ever occur to you that maybe that was voluntary, that they didn't learn this shit?
Oh, absolutely. Yeah. Whatever reason. Yes. Okay. Something they've missed out being educated by a teacher for those crucial years.
I mean, I'm not saying all teachers are awesome, but many, many, many are. And what do you call it? And I think, there's also just some idiots who, didn't feel like paying attention in class.
I agree. Completely agree. They've missed out on that. Yeah. So we're having to make up for the fact that for whatever reason, the teachers didn't get through to them when they were sort of, 10 to 13. 14.
And now they're adults, and that also goes on. Keep in mind that that's not just for flat earthers. There's a lot of people that don't believe the earth is flat, but don't understand these concepts. And they learn a lot from us watching this shit too, because as an adult, you put away childish shit. It becomes fun to watch, conflicting ideas, especially the ones that are so wrong, like the flat earth, and they have no idea. But these people don't understand the methodology to prove that they're wrong, because maybe they didn't pay attention in high school as well. So they learned a lot from us as well.
Well, the putting down of childish shit, I actually have a modification to that particular anecdote, and that is you become an adult when you stop giving a fuck what people talk about your hobbies.
Yeah.
I think that's absolutely right. It's their fundamental problem is their reasoning skills, it seems to me, as well as the two things, the reasoning skills and the ignorance of information. But a lot of it is down to their reasoning, just the way they reason about stupid things like, right, say someone's lied, Pete Shea says someone else is the same as someone else. Their basic reasoning just doesn't seem to work. And from that, of course, they can't then draw any science, they can't understand science or maths or society. They find society is oppressing them. There's all these people who seem to understand how the world works. They don't. Therefore, they want to fight back and say, well, I've got this special knowledge in flat earth or other conspiracy theories that all you don't understand. It's a way of bolstering their self-worth, because they basically don't understand how the world works or society works.
That's about it.
Hey, Gio, let me. I want to tell you that I'm about to call Full Sail, the online university, and get like the specifics of JM's degree plan, like what exactly is the prerequisites, how much science is actually going to be involved. We can do that live if you want, and I can call them right now, or we can do that offline if y'all want to stick around and listen to that conversation. Suggest any questions I might have to ask so we can for my expose.
Well, now it's obviously a bad time because it's getting late over here.
Okay. Well, I'll just do it on my own, then that's fine.
Okay. Well, just one thing. Do we know what happened to Riley and his degree? I know he's about to be kicked off it. Did it actually happen? He got kicked off?
No idea.
I don't know, but I wouldn't be surprised if it did.
Yeah,
hey, but that
no, but I'm just gonna ask him.
That puts a lot of value into his girlfriend's hands when she said that
don't put your money in.
Too much of a risk for him to use his own money or use their money.
Absolutely. So all those flatties have just spent money on Riley. Oh God, just wasting his time for a couple of weeks.
I'm sorry.
Actually, I was thinking about donating something, because any education he might get is probably an investment.
Yeah. Oh, and Gio?
Ja?
Samstag kriegen Besuch aus Berlin.
Berlin?
Mhm.
Okay, dann habe ich eine Vermutung, wer das ist.
Jojo.
Aber ist es nicht ein bisschen weit? Fährst du mit dem Zug oder mit dem Auto?
Ja, es gibt Pizza.
Ja, aber das beantwortet meine Frage nicht.
Answer the question, for fuck's sake.
Because I don't have that answer.
Okay.
The answer is no.
I'm just saying that it's a rather long drive, like 4.5 hours.
Yep.
So
for those who don't understand German, they're basically discussing something about travel plans to Berlin.
No, from Berlin.
Oh. Something with Berlin and traveling.
Well, I thought Gio only had to travel a few miles to get to this.
Yeah, I do. It's about 65 kilometers from where I am.
Gio's got it the best of all of us. I gotta drive about 4 hours as well.
4 hours? I thought it was 2.5, 3.
Shit, until you get off the Autobahn, then it's like it drags down. It's not just the kilometers, man. It's the speed limits.
Okay, well. You know, Sly, that you picked out, you're actually very lucky. Do you know why?
Wieso?
So the A3, the Autobahn 3 between Kitzingen and Nuremberg is supposed to be renovated, actually widened to 3 lanes. Now, the construction there was scheduled to start a few days ago.
Yeah.
But it's delayed. So they actually said they would start in the first week of May.
Right.
But they can't, which means that you will probably still have the ability to just drive through it without suffering 7 to 8 kilometer long parts of construction sites every 20 or 30 kilometers.
Well, then that's just driving A3, man.
Yeah, well, it's getting
A3 's
better.
always
I actually prefer the A3 over the A7 now.
Well, I never used the A7, so I don't know. But A3 is always broken. I don't think there's, in the entire, 20-some years that I've been in Germany, A3's never been a straight drive-through.
Yeah, it's getting better. At least just take a look at what happened between Aschaffenburg and Würzburg in the last 5 years.
Are we going to spend the last 10 minutes talking about traffic?
Maybe.
Okay.
Well, you want to talk about traffic, Rumpus?
No, I don't.
So let's keep talking about traffic.
Okay. Right. Okay. I'll leave you to it then.
Okay. By the way, Micro and Team Skeptic have already left. So thank you two guys for joining. It's been a pleasure.
Bye, Jim.
Cool.
Okay. So I think we should just end this right here. So Rumpus, do you have anything left to say about Riley and this stuff?
I think the key point to take away is that he thinks that he's got some scientific method for proving himself right because 1, he only believes there's only ever one cause or something, and 2, he thinks he's found the cause in changing the medium. And from that, and his belief in this ridiculous QE scientific method approach, that's his reasoning. And he's an idiot.
Okay. Sly, your final words?
Well, I'm happy to say that the weather report for Saturday still looks like it's going to be a shitty day, which is exactly what we need for this test. Yeah. So, and Riley's an idiot. So,
ding.
Ding.
Okay, to the 97 people watching, thank you guys very much for joining us in this clusterfuck. And wish us all luck for Saturday for Slice Experiment, which, just to remind you, will be happening on the eastern shore of the Rhine-Main-Danube Canal, south of Bamberg, Germany. So I'll actually be live streaming this, so let's just hope that everything works and that we get good results.
And it's probably going to be the single most boring live stream you've ever seen.
Maybe.
Maybe.
On the other hand, I have already seen a live stream of grass growing and of paint drying.
That's some things right there.
Okay, so again, thank you very much for watching and see you next time.